Hi, today we're going to continue on with particle motion section 3.4. I'll first start the video by going over some of the key concepts that we talked about in the previous class. The focus of the video today is to discuss graphs and the interpretation of various graphs relating to particle motion. You will have, or you do have, two worksheets. I'm going to walk you through the front side of each of the worksheets, and you are responsible to complete those along with the back side of those worksheets and the other homework assignment from the textbook. So just to kind of recap what we talked about the other day, the first term that we used was displacement, and displacement is no more than the change in a particle's position over a certain interval. So here I have, for a time t1 to t2, we're just going to subtract position from t2 minus the position from t1. Next we have average velocity. And so when you think of average velocity, you want to think of the average rate of change over the closed interval. And so I'm doing no more than the slope of the secant line that would pass through these 2 points of the function. Next we have instantaneous velocity, which is the derivative of position. So v of t is equal to s prime of t. And then we have acceleration, which is the derivative of velocity and the second derivative of position. We will also talk today about speed, which is the absolute value of velocity. So if I give you a velocity graph and I ask you to graph the speed graph from it, any values of v of t that are down below the x-axis are going to reflect over the x-axis up to the positive values, and we'll go through an example or discuss that a little bit later on. The other thing that we will also talk about is when a particle is speeding up or slowing down. So just to review from previous class, a particle is speeding up if both velocity and acceleration have the same sign. So if v of t and a of t are positive, then the particle is speeding up. If v of t and a of t are both negative, then the particle is speeding up. If v of t and a of t have different signs, then that means that the particle is slowing down. So moving on to the first worksheet. I am going to walk you through the front side. What I'd like you to do is I'm going to give you some information. Please put the video on pause and see what you can fill out yourself, and then we will check our answers together. The first question, first of all, this is a position graph. And the question says, when is the particle moving forwards, backwards, and at rest? So how do we know if the particle is moving forward? We would look for where the slope is positive. When is the particle moving backwards? We would look for where the slope is negative. When it is at rest is when the slope is equal to 0. So put the video on pause and see what you can come out with for an answer. Again, we could be looking possibly for intervals. Okay. So as you can see here, I tried to color code this to try to make it easier for you to visually see. The particle is moving forward when again the slope is positive. So that's from 0 to 2 and 8 to 10. It's moving backwards when it's negative, so from 2 to 4, union 7, 8. And it's at rest when the slope is equal to 0, so that would be a horizontal line. And so we're looking at from 4 to 7. Taking a look at the next question, or the next question is just changing the wording a little bit. Think of how this changes your answer. When is the particle's velocity positive? So positive velocity, we're still looking for a positive slope. When is the particle's velocity negative? We're still looking for a negative slope. When is the particle's velocity 0? We're still looking for 0 slope. And non-existent. So think about what you would be looking for non-existent. put your answers down and come on back in a minute. So hopefully what you found was that the answers were very similar to what you gave in the first set of questions. So when is the particle's velocity positive? From 0 to 2, union 8 to 10. When is it negative? Again, we're looking for negative slope from 2 to 4, 7, and 8. When is it 0? From 4 to 7. Where is v of t does not exist? So we're looking for corners and cusps, things of that nature. And so we have 2, 4, 7, and 8. Now we're going to move on to the velocity graph. And so here we're asking, again, similar questions in terms of when is the particle moving forward, backwards, at rest, speeding up, slowing down, or neither. So taking a look at this is, how do we know when the particle is moving forward? Looking at the velocity graph, we're looking for where is v of t positive. So where is it above the x-axis? When is the particle moving backwards? We're looking for where is v of t below the x-axis. And what about when is it at rest? We're going to be looking for where is v of t equal to 0. So where does it cross the x-axis? And then we already talked a little bit before about the fact of slowing up, speeding up or slowing down. So see if you can figure out the answers for those. Okay, so let's see how you made out. The particle is moving forward where the slope of v of t is positive. Where the graph of v of t is positive. So we're looking for where the graph is above the x-axis. So that's from 0 to approximately 7.4 and from the interval of 9, 10. Where is the particle moving backwards is where v of t is negative, so it's below the x-axis. So we're looking at the interval from 7.4 approximately to 9. It's at rest where it crosses the x-axis, so at approximately 7.4 and 9. The particle is speeding up when we have both a positive slope and it being above the x-axis, or a negative slope and below the x-axis. So here the function is speeding up from 0 to 2. It's also speeding up from 7.4 to 8. And then it's also speeding up from 9 to 10. The interval from 9 to 10. The function is slowing down where the graph of v of t is positive, but its slope is negative, or vice versa. So here we have from 2 to 4, from approximately 7 to 7.4, and from 8 to 9. And it is neither slowing up or speeding up or slowing down between 4 and 7. Taking a look at the next set of questions, it's asking you about acceleration. We're looking at a velocity graph, but we're referring to acceleration. So where is the acceleration positive? So we're looking for where is the slope of v of t positive. Where is acceleration negative? We're looking for where is the slope negative. Where is it 0? What would we be looking for? And non-existent, what would we be looking for? Everybody go ahead and see if you can figure out your answers for those. Once again, let's check our answers. Again, the particle's acceleration is positive when the slope of v of t is positive, so that would be the interval from 0 to 2 and 8 to 10. Where is it negative? Again, we're looking for where is the slope of v of t negative. And so we would have from the interval from 2 to 4 and from 7 to 8. Where is the particle's acceleration 0? Is we are looking for the interval from 4 to 7. Where does it not exist? We're looking for corners and cusps. So that would be 2, 4, 7, and 8. Okay. So now we're moving on to the next worksheet. So pull that out, please. So in this worksheet, we're going to talk a little bit about graphing a velocity graph based upon a position graph, and also graphing a speed graph based upon a velocity graph. You will, for homework or part of this asynchronous assignment, you'll be completing the second side of the worksheet we just did, along with the second side of this speed worksheet for additional practice. So this first question we give you a position graph, and it uses a little bit of a different word. It's saying, when is the particle moving left? Left is the same as when is the particle moving backwards. And when is the particle moving right is the same as when the particle is moving forward. So this is very similar to the previous worksheet that we did. So see what you can figure out for an answer, and we will review the answers in a moment. Put the video on pause and complete these answers. Okay, because I like to color code, I color coded this again. So the particle is moving left when the slope is negative. So that's the interval from 0 to 2 and from 6 to 7. It's moving right when the slope is positive. And I'm going to say from 3 to 6. Even though I know that there are different slopes going from the interval from 3 to 5 and from 5 to 6, the particle is still moving right over that interval from 3 to 6. And then also the union from 7 to 8. The particle is at rest when my slope is equal to 0. That means the position is constant, and would say from 2 to 3. Now, taking a look at this graph and my color coding, this is going to help us graph the velocity graph. The velocity graph consists of graphing the slopes over the different intervals here. Okay? The first thing you want to make sure is that you label your graph here. So this is my graph of v of t. And what I need to do is I need to figure out what is the slope. Is the slope the same all the way from 0 to 2? And what is that slope? I hope you all figured out that this slope is -2. So from the interval from 0 to 2, the slope is -2. So I am going to use open intervals, open circles, from time t is equal to 0 to t is equal to 2. And my slope is -2. So it's a series of horizontal lines that you are going to be drawing based upon this position graph. So taking a look at the interval from 2 to 3, what is the slope value from 2 to 3? I hope you said 0. So again, open intervals, and then again it's right here from 2 to 3. Now going from 3 to 5, what is the slope? Because it's different from 5 to 6. So figure out what's the slope from 3 to 5. And hopefully you figured out that the slope is a +1. So I'm going to graph from 3 to 5, +1. And then from 5 to 6, the slope is 2. So again, open intervals. Now from 6 to 7, what is my slope? The slope is going to be -2. So I'm back down here, -2. And then from 7 to 8, the slope is a +1. So again, +1, again, open intervals. And we should also note on our graph, this represents t in terms of seconds. It's super important that you have your graphs labeled and labeled properly. So now the next graph that you need to do is speed. So speed is the absolute value of velocity. So what that graph is going to look like is still a series of horizontal lines. However, anything that is below the x-axis is going to flip over the x-axis into the positive value. Remember, absolute value. So here, if this slope is -2, the absolute value of -2 is +2. So this graph here would go in this position. So what I'd like you to do is put the video on pause and see if you can come up with the rest of the absolute value function. So I hope you were all successful in graphing your speed graph. Make sure you have your labels. And again here, please note at t is equal to 6, it's an open interval because at that point there is a, what do we want to call it? There's a break in the graph, or cusp corner of this position. And that'll do it.